Hi, so this is Laura from Kaggle, and we're here with the second place winners from the Google Research Football competition. And I guess if the host can introduce themselves first.
Yeah, so maybe we'll start from the City Football Group side. My name is Greg Slimer. I am the Chief Technology Officer for City Football Group. Congratulations to you for an excellent performance in the competition, and we look forward to hearing all about it.
Thank you. Thank you.
Morning, guys. I'm Rayaka. I work for City Football Group here in the UK. I look after IT development.
Hey, my name is Brian. I lead the data science team across the football aspects of the business. So sports science, football performance, and player recruitment and scouting. Really looking forward to kind of seeing your presentation and hearing more about kind of the fantastic work you've done. So really looking forward to that.
Thanks. Nice to meet you. And next one.
Well, my name is Ling Feng. I work for City Football Group. I'm based in Chengdu, and I look after the club that we invest in called Sichuanzhou now.
Yeah, so the next.
We have one more, right?
Yeah, I think I see Scott's just joined us. Scott, can you hear us?
Sorry, guys, it was just connecting. Hi, Scott Mann, Chief Executive Officer of CFG for China.
Hello. Hello, nice to meet you.
And then on Google side, it's me, Peter Stańczyk. I work on Google Brain, and I'm behind the environment, and I'm happy to see you enjoying the game.
Yes, thank you. What's wrong? Hello, this is Salty Fish, and we are very pleased and honored to see you guys, and we are really looking forward to this communication interview, and it's such a honor opportunity. Thank you, guys.
So, should we start? Go ahead and get your presentation up.
Okay. Well, wait a minute. Cool. Oh, oops. Sorry, guys, it's stuck.
Okay, no problem.
If you can't get it going, I can also present. I think you just tell me when to change slides. Yeah.
And maybe it's nice for you to present.
Let's
because
see.
something is wrong.
Let me just
Okay.
Next page.
Ah, here we go. Okay. Let's see. All right, are you able to see that? Good.
Yeah.
Okay.
Wait.
All right. Well, go ahead and get started.
Okay. Can you get it from the start? Yes.
Is this the newest points, or is it updated?
Yeah, this is the one that you sent, I think earlier today.
Okay, so
Okay. So shall we start? Let's start. Okay. So thank you guys for holding this wonderful competition. Firstly, I think we should introduce ourselves to you. Please, next page. We are from a company. We are from the Fuxia Lab of NetEase Incorporation. So NetEase is one of the largest company in China, a game company in China. And the Fuxia Lab was founded as a department of NetEase in September 2017. We are the first game AI lab in China, and we mainly focus on the application of artificial intelligence in computer games. So the major research directions of us include reinforcement learning, user personal, computer vision, NLP, and so on. So you can get more information on our website. Next page, please. The next page. Thank you.
Sorry, it's not going.
Let's get started.
Yeah. Let me see if I can just. There we go. Okay.
Okay. So the team members are from the area group of the Fuxia Lab. We have more than 10 people involved in this competition, but there are only 3 full-time members. In the last 2 weeks, we have 4 full-time members. The other members are the advisors and some colleagues for providing some support. So the area group, we have published more than 20 papers at the top conference of artificial intelligence. We also have some experience in applying reinforcement learning in game scenarios, such as basketball game, such as massively multiplayer online RPG game, and also the game testing scenarios. So this is information about us. So let's go through the main part of this interview. Next, thank you. Still get stuck.
Yeah, it's stuck. Sorry. Okay. Let's go here.
Okay, the solution, we use reinforcement learning as the main technical in this competition, but it's not just application of a reinforcement learning algorithm. It also involves many other parts, such as the neural network structure, the training approach, the state representation, and also the reward design. We also, besides reinforcement learning, we also use other techniques, such as surgery techniques, such as Greek learning, such as imitation learning, and also even some fixed rules. Without these techniques, we think we cannot create very strong models. Also, another important factor in this competition, we think, is the computing resources. We believe that if we don't have sufficient CPU cores, we cannot get the second place in this competition. Okay, it's quite important. And also we conduct further studies after this competition because we have some problems during this competition, but we did not have enough time to get the answer. For example, the influence of the random seeds on the performance of the algorithm, or the performance of some reward shaping methods, and the performance of many other neural network structures. We have conducted such experiments after this competition. So this is overview. The next part. The first part maybe is a training approach. Yes, a training approach our training approach is a combination of PVE training and self-play training. PVE training means player versus environment training. Our training process contains three steps. So firstly, we train our model against the easy rule-based AI, which is provided by the football environment. This is for learning the skills of moving forward and the shooting skills. Next, we train our model against the hard rule-based AI, which is for further enhancing dribbling and shooting skills. Next, the last step is self-training for further enhance the skills of our models under some sophisticated techniques. So we can see a drastic change, a big change of the playing styles of our models after PVE training and self-play training. So can you help to play this video, these two videos?
Not sure if it's gonna work.
Okay.
These two at the bottom, right?
Yeah. So after PVE training, our model is only able to perform dribbling and shooting. But after self-play training, our model has learned some sophisticated tactics such as short pass combination. Okay, next page. Okay, another important component of the training approach is how to select the opponent team for training our models. There are many papers, there are many related works in the reinforcement learning community, but here we only use very simple heuristics. That is to select the latest model as the opponent team with a very high probability. And at the same time, to randomly choose a historical model as the opponent team with a small probability. This is based on assumptions that newer models are always stronger than older models. It's quite simple, but very effective. We also tried other training approach, other mechanism for opponent team selection, but it's not better, such as the selection with error score evaluation. But it's not better than the simple mechanism. And also the error score evaluation process costs a lot of time. We also tried self-play training from scratch without PVE training, but we did not get a very strong model. We think the reason may be that it's difficult to train the learning algorithm with a fairly skilled opponent team in the initial stage of the training process. Okay, this is a training approach. So the next part maybe let me think the state representation. Yes. Okay, we just use vector state representation in this competition. We found that a vector state features is also able to create a very strong models. This does not mean that image features are useless. Actually, we did not use image features because we didn't have so many GPU cards. So we just use vector state features. But the difference is that we use multi-head vector state features because we did not use single vector. We did not use a single vector to represent states. We use multiple vectors to for distinguish between the different groups of information, such as ball information, such as ball owner information, the active player information, also the feature of the self teams, and the feature of the opponent teams, and also some features of the actions. Okay, so this is the original state feature we used. But during the middle stage of the competition, we found that we some important information. The next page, we found that in the middle stage of the competition that some important features are ignored, has been ignored, such as the player, such as the red card, the yellow card, the offside information of the players. We think that's very important information. So we use techniques to add these features to our models. Next page. So there are some important features that we missed during the early stage of the competition, such as the angle features, such as the tired factor, yellow card, red card, offside information of the players. So we use surgery techniques to add this state feature to our models. We think the most important features are the last row of this table, which is the historical action sequence of the players. So the next page. Okay, this finger is quite strange. This finger shows that the performance, the ability of our models in different stages of this competition. So we can see after using the surgery technique, the ability of our model becomes much more stronger. Oh, okay. The next page, please. Next is a neural network structure. Our neural network structure is quite simple. We use a fully collected network structure in this competition. But since we use multi-head state representation, this structure is a little bit different from the normal structure. We can see that the lower levels are private layers for each head of this state representation, and the higher levels are three shared layers, three shared hidden layers, and which is followed by the output layers of the policy and Q values. Okay, next page. For the reward function, the final reward function we use is also quite simple. For PVE training, we just use scoring rewards and the checkpoint rewards provided by the environment. And for self-play training, we use the scoring rewards. We only use the scoring rewards. One thing should be noted that the checkpoint rewards is very useful reward signals because it enables the agents to learn dribbling and shooting skills very quickly. But if we want to further improve the performance of this model, of our model, we should ignore the checkpoint rewards because such rewards lead to no passing agents. Okay. The next page, please. Actually, we have tried many other types of reward function in our experiments because we want to get some other models with different behavior styles. For example, we design ball positions reward for getting a tackle preferring agent. We also design ball passing rewards for getting a pass preferring agents. But the conclusion, the results is that different rewards, different shipping rewards really can lead to the change of the playing styles of the models. But correspondingly, the strengths of the model may not be very, very strong. Sometimes, usually, the models may be very, very weak. For example, Here the figure shows the models, how the ability of models changes after we add passing rewards to our model for training our models. We can see that there is increase of both the ball passing times and the ball passing successful rates, but the cost is that the scoring ability of our model is reduced. So which means that our model becomes weaker. Okay, next page. So the point is that we should try to use simple reward and try to avoid the complex reward shaping methods in this competition. The other techniques used in this competition, such as we use legal action mask for avoiding taking unnecessary actions. We also use curricular learning for more efficient exploration in the state space. We also use imitation learning to learn from the other team. Particularly, we use imitation learning to look for the policy of the champion team we kick, because we want to find the counter policy against this team. Okay. So that's the solution of the salty-fish team. So the next may be the results and the demos. Yeah. Okay. This is the examples of playing corner and throw in. We did not use learning algorithm to learn. We just use fixed rules, which is quite effective. So for playing corner, actually we learned from the weak kick team. We just learn how the action performs, the action sequence, and just write this action sequence in our solution, in our code. Okay, next. This is a kickoff strategy learned by a model. First we can see the ball player dribbles back, and when the other teammates move forward, and then the ball player performs a short pass to the players in the bottom, and then the bottom player dribbles ahead and makes a goal. So this strategy is quite effective for scoring in the early stage of this competition. Okay, the next page. This demo is a strategy, a typical strategy learned by a model, which is a short pass combination. Our model prefers to perform short pass rather than perform high pass and long pass. Okay, can you play this video? Or it just has problem?
It kind of just plays on its own if it works.
Okay.
Yeah.
That's all right. So the next page. This is a strategy by imitating the champion team we kick, which is a very effective scoring strategy. That is to going along the wing side and making a button pass and then making a score. So, but finally, within the competition time, we did not get this strategy. We get this strategy after this competition by more and more training. Okay, so next page. Oh, this is a this is a very interesting strategy learned by a model. In this situation, we can see the goalkeeper of this open team is out. So our model found this situation and perform a high pass from player number 2 to player number 9, which directly leads to a goal. High pass to the player number 9, and this directly leads to a goal. So this is this phenomenon happens many times in our offline test. Okay. Next page. So the next is the further studies. We conduct many experiments after this competition. The first one is to answer the question that whether random seeds has big influence on the learning performance. The answer is yes. Answer is yes. We conduct 26 rounds of experiments that in each experiment, we train our algorithm against the internal rule-based AI. We can see from the figures that only in the half of the experiments, our algorithm finally achieves positive goal difference values after convergence. In the other half experiments, the performance of the algorithm is not very good. So random seeds really matters in this football environment. Okay. So the next experiment is to answer the question that why we have to use multi-head vector status representation in this competition. We compare the performance of models with multi-head state vector representation, single-head vector state representation. So the answer, the result is that our choice is right. We can see from the figures that with different random seeds, the models with multi-head vector state representation performs better, or as well as the models with just a single vector state representation. Okay, next. Next two experiments studies the performance of novel neural network structures, the performance of the network structures in the football environment, such as action semantic networks and the graph neural network. First, the action semantic network is a joint work of our team and Tianjin University. We found that maybe this structure may be very suitable for this football environment because the different actions of the players may need different state information. Okay, but the results is that the actions semantic network next page. But the results is quite negative that with action semantic network, this is the perform page, previous page, the last page, last one. Okay. Here is the results of the action semantic network. We can see that the performance of the action semantic network is not better than, is much worse. It's much worse than the performance of the algorithm with just the F.C. structure. Okay. Last experiment is a GNN, is the performance of GNN. The results is similar, that the performance of the GNN network or GAT, they are not perform, they did not perform better than the normal FC structure. Maybe this network structure are too complex. Okay. So this is our report. Thank you for listening.
Really good, really impressive, guys. Thank you very much. Not just in terms of obviously the work you've done, but the delivery of that, so much so that as you went through it, you started to answer any and all the questions that I could come up with as we went through it. So I'll start just by kind of making a few kind of short comments, which we can follow up at a later date as well. I really liked the approach of almost a simple approach that you took to training and realizing that actually sacrificing any minimal potential gain there possibly could have been for the performance and the speed. If I talk about it in the football environment, it's something we do a lot of. Sometimes, you know, you might get a minimal performance gain, but it impacts the performance of the model or whatever piece of work we're doing. So I really like the fact that you did that. I like the fact that you went through and identified some of the kind of the components that you'd missed when you were looking at the. So a prime example, right, is the historical action sequence. It's something that a lot of the more complex football models, it's a lot of the football models that get used currently miss out, and they look at kind of they're state-based. They're looking at this moment in time rather than looking back at how we've got to this moment in time in the play. And I think you said that had a big impact on the outcome, did it as well? Was that one of the key components you added in during the surgery that helped?
Yeah, surgery technique helps quite a lot in our solution.
That's good. One of the things that was interesting, you chose fixed rules for corners and throw-ins. You had what was the kind of reason behind this decision?
Not very good reason, but we just find that we kick team, the champion team, performs corner very, very well. So we just see how they perform. We can see the action sequence performance by their team in the test in the videos. So we just copy this action sequence and make it and write it in our code.
Okay, and another reason is that the side kick and the corner kick it occurs not so frequently during the training, and the samples are are not as many as regular training. So they didn't learn well for the model to do the corner and do the throw-in. So we just write some rules, and we also consult some friends who is really good at football, and he says when you're doing the corner, you just shoot at the goal, and that's the place that's most dangerous for the opponents. And we think, and by copy and by mimic, we kick, and we think this is a nice strategy, especially during the corner.
It's interesting, right? Because it's somewhat that approach is very similar to what we do in football in terms of in the non-virtual version, the non-simulated version, in the sense of throw-ins, corners are the one time, or one of the very few times within matches where coaches can almost create that set play where they can define everything that their team does. Whereas the rest of the game, a lot of the emphasis, whilst they play within a tactical framework, it is about the players kind of learning the game and kind of self-evaluating what's going on with themselves and the team and the opposing team. Set pieces is very much, coaches spend hours working on set piece routines, which are essentially fixed rules, right? Player A stand here, player B stand here, player Z who's going to take the throw in is going to put it into this spot here. So it's just interesting to see kind of that approach. I hadn't, if I'm honest, I hadn't considered the fact about the limited kind of sample size, let's say, to actually train on. But it is something that we do have an issue with in the real game as well, because of there are certain teams that have lots of set pieces and there are certain teams that have very few. And in general, we'd like a bigger sample size than that. And actually, it's one of our reasons for wanting to be able to simulate the game of football, right? To almost increase our sample size of data if we can create a realistic kind of version of the game. I love the goalkeeper rushing out bit, by the way, when and playing the ball in behind. But moving on from there, you talked, I was going to ask you a lot about where would you like to go in future, but you touched on the future enhancements a lot at the end. One question I would have then would be, if we were to run this competition again, what would you like to see done different from our side, and that's kind of Google, Kaggle, and CFG?
If the competition put again, yes. What we expect from you?
If we were to run it again, do another competition.
Okay.
Yeah, that's a good question, because actually there's a huge gap between the virtual game and the real game. And actually, if we want to use like reinforcement learning or algorithms to find solutions to the football game. I think it's better to module or build the virtual game as close as to the real game. Because actually in this virtual game, during the competition, there still be some unreasonable sports, like unreasonable occasions, like what we detected. Their algorithm just find a nice place to trick the players. They drive the ball to the corner and they kick it to the goal when there's no defenders around the player, and that player just take advantage of this mechanism and just shoot it. Their algorithm find this shortcut, and actually in the real game, I think there should at least be one defender around the players when they are getting closer to the goal. There should not be so large spares.
Yeah, I think that's a really great point. We can touch on more in kind of follow-up conversations, but it's something that we've looked at kind of briefly in the past, where we looked at tethering players. So there are certain players that almost if they get pulled out of their zone that they typically play on the pitch, there's almost like a tethering force that pulls them back into that area, meaning that you can almost never leave one area of the pitch really vastly open. I think you're right, pulling it to make it more applicable to the game, there probably has to be some further rules applied or conditions applied. But yeah, no, it's really interesting. And I guess one of my questions is, from your expertise, do you think that you could possibly, I don't necessarily mean you, I mean, it is possible to get to a realistic football simulator to really mirror the game?
It's very hard, actually. Also, our company also have some soccer games. You know, Netis is maybe the second largest company in China of the video games, but actually it's still be a very difficult.
Okay. That's it from me for a moment, guys. I don't know if anyone else has got any questions.
I had a quick question for you. What do you feel is unique about your work and your approach? What is different to the other competitors you saw?
The major difference that we maybe we have already learning framework before this competition. So when we join this competition, we just rely on our learning framework. So it's very convenient for us to train our models. We have already chart with some other teams in top 10 teams. Maybe our algorithm, we use impel algorithm. Most of the teams PPO algorithm. I think this is one of the difference. And also, we have tried many other experiments. For example, we implement the behavior tree. We just implement the C+ code, the ELISA controller, of the internal environment. Just we use Python. We use Python code to implement the internal AI of the environment. We want to provide a more more wonderful behaviors of our models, but this is not in the final model, in the final version of our model. But currently, we are still working on this this project. This maybe we have done much more experiments in this competition. So other difference maybe we have more computing resources, but only in the last 2 weeks we have more than 2,000 CPU cores, and you know the champion team has more than 15,000 CPU cores when they perform training. Yeah. I think this is a very big advantage over the other teams.
Yes, I noticed that you said you found some of the shortcuts after the competition from more learning. So I guess if you had more compute resource, you would have found those during the competition.
Yeah.
Thank you.
Any other
questions? Yeah.
Yeah, so from my side, I wonder if other than environment not being super realistic, do you have some comments about it? Like anything that could be improved or added some features to enable some directions of research like multi-agent, model-based, or...
I'm sorry, Peter, can you repeat your question?
Sure. Like I just wonder if you would like to see something added to the environment or some issues fixed, if you noticed any, something outside the reality of the environment, but like functional wise, compute, resource usage, feature wise.
Currently, no. Currently, no. I think this is quite well. Environment is quite well.
All right, thanks.
So I guess the other thing to touch on then is around kind of the follow up and I guess your prizes and where we go from here. So obviously, with the pandemic, it's currently going to be very hard to get you on site. As you can see, we're all working from home at the moment anyway. But it's something that we could still look to do in future. In the meantime, it would be great to set up a call between the CFG team on this call and also the wider data science team at City Football Group and at Manchester City, and have a call with you guys for two reasons, right? One, for us to delve a bit deeper into what you've done, but also for you to ask questions of us, right? Understand, what the landscape is in football in terms of data science. Understand why we at City Football Group were interested in working with kind of Google and Kaggle on this competition, and just to ask us kind of any general questions that you think may help the development of your models as well when it comes to kind of this competition and future competitions that may be run. So I'll touch base with you after this call. I'll send you an email and we can arrange kind of a date and time to have that follow-up call.
Sure. Can we ask some questions?
Yeah, we also have some questions.
Go for it. The floor is yours.
So regarding the final behaviors of the teams, such as retake and Saltyfish, is there something useful to the training of the players in Manchester City Football Club? I mean, are the behaviors insightful for you guys?
What I would say is, for it to have a true impact, I think you answered this already, which is for it to have a true impact, we probably need to step it a little bit closer towards being more realistic to the game. But what I would say is some of the things we've seen from a lot of the entrants actually is that there are tactics and strategies that seem to be evolving. You talked about the kind of getting the ball, what we call getting the ball wide in behind, and the cutbacks or low crosses. Does that make sense to you? I think you termed it as I forgot what you termed it as now. I'm just looking through my notes. The tactic of I forgot what you termed it now, but the idea of getting the ball down the side of the box towards the goal line for the player to cut back or to cross it into the box. I think you uncovered that as one of your features. There's been a few things like that have come out throughout kind of the various entrants, including kind of yourselves and WeKick, which mirror a lot of the thinking about what is the best way to create goal scoring opportunities in football. What that does give me is it gives me kind of some confidence in the fact that the virtual game has the ability to somewhat replicate what is beneficial to the real game. Like you say, I think it needs to be more realistic first, but it's stepping stones, right? It's kind of just slowly getting there, bit by bit. And also the fact that you talked about fixed rules for the corners and the throw-ins. I'm still thinking about that in practice, but it's interesting how it imitates the game, or the way we think about the game and the way coaches think about the game really closely. So in short, I don't think there are any big learnings now, but I think there's been big steps taken towards getting to that point where big learnings could be made.
Yeah, we are also looking forward to that.
Yeah,
and another question is for Kaggle. Maybe will there be 5 versus 5 competition later?
So I guess I can touch on that. We are discussing that. It's not clear whenever it's gonna be 5 versus 5, as it was on the game server originally, or maybe 11 versus 11 with adaptive multi-agent control. Basically, I guess you might have seen the V2 action set where you can pass execution of actions to the built-in AI dynamically. So basically, you can dynamically decide which players you control, and we might launch the competition that just exposes this functionality. So you can dynamically train like one player being controlled, 2 players, and etc. etc. Because like 11 versus 11 full multi-agent might be too hard. 5 versus 5 like doesn't sound very realistic in terms like not close to a real football, but yeah, I hope it will happen anytime soon.
Yeah, because multi-agent learning is far more difficult than the single-agent learning. And also during the single-agent learning, because some players are controlled by rules, and also it may be not good or not easy for the algorithms to find the nice solutions or the general solutions to search some tactics, because some players are fixed, and maybe for the multi-agent learning, there will be more interesting behaviors regarding the tactics for the real players, for the real games. And also another one is will there be blogs or posts or news after this interview? Because maybe it's also a good opportunity for us to do some PRs if Google have some posts regarding the competition or stuff like that. Yeah, Laura?
So as far as I know, that is also being planned, like summarizing feedback that you provide. but Addison, who didn't join the call today, is like driving that. So I will follow up with him to get the current status there. But yeah, this is definitely also on the plate.
Okay.
Is there any other questions?
Yeah, and also I have a relatively big one that since Google is a top research institute is on the earth, so will there be other plans to make something big after F-star or any huge projects regarding
like inside note is that like we try to do something with football, but actually we're trying to address a slightly different environment, being like FIFA. However, like the lawyers' discussions got research stuck on that. That's why we like ended up releasing our own environment and pushing in that direction, which is not that much publicity related, but more focusing on the research. And that's why we are also looking at different ways to enable like multi-agent and maybe model-based directions for the research, which are interesting. But for now, we are not looking at like doing a big thing as AlphaStar at this point, at least.
Okay, that's it. Here's our questions.
Fantastic.
Great. So, well, I guess that's it. Congrats again, guys. Good job.
Thank you.
And yeah, we're all done.
Congratulations, and we'll be in touch very, very soon to discuss further as well.
Sure. Okay, you can just email us for the meetings.
Will do.
And hopefully see you soon on the multi-agent people.
Yes.
Yeah, looking forward to that.
Looking forward.
Okay.
So
Thanks, guys.
is there any-
Take care,
Okay,
everyone. See ya.
Congratulations.
Thank you.
Thank you. Bye-bye.
Bye.
哎呦我操，这英语不会说。
比我好吧？我是看到这么多人准备好的东西都全忘了。
有38分钟。
我好像全忘了，然后就不知道该怎么说。
但是那个 P 座
We're part of this.
他的口音太重，我听
他
不
可能是
Using the centering techniques, the ability to take honest directions. We also use collective learning for more efficient exploration in the state space. We also very good.
这是卡住了还是什么？反正录的声音。
So when
太卡了，电脑。
那个的问题没有回答的很好，因为没想好怎么回答。他问我们跟其他人有什么不同吗？我绕了半天说我们实现了行为树啊。
哎呀，我操！
可以啊，如果学的
这个录制怎么出错了？实在不行让那个 Laura 录，然后让 Laura 发。
应该有录啊。
有录吗？王博录了吗？王博不是录了吗？